and now we are going on to horizontal shifts, and that will look a little bit different. And so that's why we looked at the vertical shifts in detail, and now we're looking at the horizontal shift in a similar detail because it's slightly different. So let's take a look. Here we are looking at y equals f of x minus 6. Now first of all, we notice that we don't have f of x like we had with the other one, and then we did something to our function value f of x, but here we are actually changing at what x we are taking our function value off. So instead of looking at f of x, we're looking at f of x minus 6. So let's take a look at our function value at x equals 9. So this one over here. So if I want at x equals 9 to know what now my new function value is, what do I need to do? Well, I need to look 6 steps before, so at x minus 6, to see what function value I would like to have here. So if x is 9, I'm going to look to this function value, 6 lower, and say, oh, so that is 13. So I'm now writing my 13 over here. So I take the function value, when x is 9, I take the function value of x minus 6, which is 3. So I take the function value of 3. Now, if I do the same thing with 3, I now look 6 to the left and write down the function value at 3. So I take the function value of negative 3 and write it down at 3. Now I do the same thing with negative 3. I look 6 to the left and take that function value, and so that is 12. So I take that one, and again I do the same thing with my function value at x equals negative 9, and as you can see, I will look again to my left and have that. Now when I look at negative 15, there's nothing more to look at. However, when I have 9 plus 6, so at 15, I could take, again at 15 I can look to the left, there is still a point, so I can put my last point here. Now when I connect all the points, what appears to have happened is that my function actually shifted to the right. So because we're always looking to the left to find the function value, basically what happens is the appearance is that it shifts to the right. Now once I know that, what I can do is now realize that whenever I have x minus 6, so f of x minus 6, what really I'm doing with my function is I'm shifting everything to the right. That means if I have a point, so if I focus again on my table, negative 15, 4, that means my point now is my x changes and it becomes negative 9, 4. See, so this is the point down here that we have created, and again it shifted 6 steps to the right. I like to kind of think of it as that if it's inside the parentheses, so if the x, that means the x is affected, and nobody likes to be boxed in, also not into parentheses, and so the x direction is kind of rebellious. Why in the y direction, like we just saw, everything happens kind of intuitively. So if it says plus 4, it shifts up 4. Here we kind of want to do it the opposite, and so in the x direction everything happens opposite. So when it says x minus 6, really what we're doing is we are shifting everything to the right 6. I'm going to fill in the rest of my points here, and now I'm going to take all my x's and shift them 6 to the right. That means I'm adding 6 to each of them, creating the following points. And as you can see, all these points are the ones that we actually just graphed. And so once you know what each of the transformations does, you can actually use the table to first figure out what your transformation you're what's going to happen to each of the points and then graph them, as we'll do in the next example. So what does this now mean for our data set is that basically everything is shifted 6 months forward. So the values that we usually would have, for instance, in January, we are now having in June. That means everything happens 6 months later. So since our function is shifted to the right by 6, our carbon dioxide values in general happen 6 months later. So now we are looking at a similar situation, just the other way around. Y equals f of x plus 12. So you're probably having already some ideas of what might happen. I would like to this time around start with the table, and so show you how, if graphing, seeing it visually is not so your thing, you can work with that from the table. Now here we basically have to think about already and know that what happens inside is the opposite. So we are looking for f of x plus 12. That means our x value will shift to the left 12. So when we fill in again our table here, where we have our usual points, I'm going to start with that again. We can now take each point and run it through the transformation, and so in this case we'll be shifting each x value to the left 12. So let's see how this works here. We have negative 17 minus 12 will be negative 27, and then our y value remains the same because this is a shift in x direction, in the horizontal direction. Now we'll do that with the rest of the points, and that is basically the general model. You take a few points, you select them. In this case they're given to you, but usually you select your own points, and then you run them through the transformations. And later on we'll do also examples with several transformations at the same time, but right now we're always focusing on one transformation only. So let's fill in the rest of the points. So now that we have all our points, we can now graph them on our graph. Or the other way around is we could have again taken a look at the function value of, for instance, f of negative 15. We find 12 steps on the right, which makes it look like the function shifts 12 to the left. So we are taking our point negative 15, 4 and move it over to the left. So it ends up at negative 27, 4. And then we do again that with every other of the points that we have. And so now that we have our points, we're going to connect them. And now you can see how the whole function has simply been shifted left 12 units. And so you might also have noticed that our whole scale, we had to extend a little bit to the left in order to make that happen. And so that will also be important as you're making your own graphs, to pay attention to what the transformation is, so that then you can make the scale and the graph accordingly. And again, what has happened? Our entire function has shifted left by 12. That means 12 months. So our carbon dioxide values happened 1 year earlier. So that is as if they had happened 1 year earlier. So to recap, when we have now our values of, right up here again, f of x minus 6, we shifted right, f of x plus 12, we shifted left. So we can summarize that over here, that if we have f of x plus h, then we can say if h is greater than 0, so our plus 12, then our function shifts to the left h units, and then if h is less than 0, then we can say that our function shifts right h units. And that is counterintuitive, and that will continue like that, that everything that happens on the horizontal axis in x direction will be opposite of what it looks like, while when it happens to the y, then it happens exactly like it says it does.